My name is Ali, and as you probably most of you know me, I'm the Product Manager of SOLIDWORKS Electrical at Intercad for Australia, New Zealand region. So I've done many webinars in the past, and here I am back again with another webinar. And today we'll be looking at how we can get productive with SOLIDWORKS Electrical. So to those of you who don't know much about myself, I've been with Intercad for almost just over 2 years now. Prior to that, I was working in the field as an electrical engineer for about 4.5 years, 5 years time, and that's where I've gained most of my electrical CAD experience as well in regards to electrical drawings and things like that. So today we're going to look at it. What are some of the most laborious tasks in electrical schematics, how we can automate those tasks and get productive in overall design process of SOLIDWORKS Electrical. Now, should you have any questions, please let me know, and I will answer as I go along, and I'll try to some of the other questions or some questions. I'll try to get back to almost all the questions towards the end of the presentation. So again, if any questions, you can ask me while I'm going through. I'll keep track of all the questions that come through, and I'll answer all these questions towards the end of the day, towards the end of the presentation. So should you have any questions or anything that you want to ask, there is an option within this GoToWebinar where you can raise your hand. If you press the button, I'll unmute that particular person and take questions from them. Also, you can type in your question if you don't want to speak on the mic. So, all right, let's get going, and we'll start off with a bit of introduction to what we're going to be looking at today. So today, first of all, what we're going to look at and how can we simplify the electrical process, get rid of some of the laborious tasks, manual tasks, and automate them. And also, we'll look at what sort of productivity gain we can get from those by automating those tasks. Once you look at that part of the electrical side, we will then look into that integrated product development, which by that, how can we integrate our electrical designs into the mechanical design, and then we'll introduce you to the electrical 3D technology, see what that is. All right. From my own personal experience, and after taking several interviews in the past 2.5 years with many engineers with experiencing from up to 30 years of their experience all the way to the 1-year experience, most of the engineers have come up with a similar answers. So what we come up with, the typical electrical design process begins with someone starting off the drawing by putting some symbols and then lines that represent wires or cables, whether they are communication wires, communication cables, or electrical, or even pneumatics or hydraulics. There could be pipes, so lines could represent anything. And then once you've done those schematics, basically you put all the text in there. For example, I'll take my mouse there. It's got this Allen Bradley, for example, written, and also the terminal numbers of that switch, and also I've got this push button there, and all the text basically gets entered manually. Then you go into documentation phase of the schematics, which is basically you look at what's in your schematic, so you can create a bill of materials out of the schematic. And then you look at how many wires you've got, where they're going from to. You produce all the cable schedules based on that as well. Then you also produce possibly termination diagrams and all these documents that you've then manually prepared, either in Excel spreadsheet or some other way of manually. And then obviously you've got to make sure that what's in your cable schedule, for example, is 100% accurate as per your drawing. Now, if something does get modification and just change, then the whole process gets repeated again. You change the name of the circuit breaker, then obviously the wiring list needs to be updated, and so on. So other document needs to be updated. And if it's a manual process, then it takes a lot of time. I'm telling that from my own personal experience as well. So with SOLIDWORKS Electrical, what we trying to bring on board is a very simplified development tool for the schematics, for the design part or phase of the drawings, and completely automate most of the tasks, perhaps, I should say, of the documentation and auditing phase. So that's pretty much what we're going to focus on today on most part of the presentation. But before we actually go into the software, there are a few more slides that we would like to go through. Okay. So in a nutshell, I said how that SOLIDWORKS Electrical offers a simplified tool and automates that. How does it do that? It's basically a cross-discipline collaboration with the help of the SQL database that runs in the background of this tool. Okay, so in this, as I said, it's a database-driven tool. It's a project-oriented software. You work in a project environment where you've got several types of documents. Could be a system architectural drawing, or like a single line diagram. Then you've got the schematics, reports, even all the way to the 3D can be included into a single project, so you don't have to hunt at 15 different places to find the right file. How does it collaborate? Obviously, if it's a database-driven tool, there must be something in the database. In the database, there is a huge library of symbols covering not only just electrical, perhaps pneumatic and hydraulic as well, and also covering PNID as well, and also some other symbols relevant to probably harnessing industry as well for automotive mobile type industries. So, as I said, very comprehensive libraries of symbols, not only just the symbols, that is a library for also the manufacturer parts as well, approximately 500,000 parts from different manufacturers like Allen Bradley, Siemens, Schneider, ABB, and various other manufacturers in there as well. So, and those libraries are very easily accessible either from the electrical side of the package, which is the 2D, or if you're within your team, there are users using the 3D, so SOLIDWORKS, it can be accessible from there. The library contains all the metadata, for example, what symbols should be used in the single line diagram, what symbols should be used in the schematic, what 3D component should be used, or the model within the 3D or the 2D footprint. Okay. Very easy to customize this library. You can bring in your own existing symbols, models, and everything in there. There are very easy to use import tools available. And apart from what comes onto the local, with the local install, there is an online portal as well, so where you can download. I guess a couple of more slides before we jump onto the actual software demonstration. It's not only just a drawing tool, it can also act as a verification tool. So, for example, if you make a mistake and join two different types of wire, 12 volt to 24 volt, it will give you a warning on the straight away that you've joined a short circuit. If you overuse a contactor, or if you've got some spare contacts left on a contactor, it will flag you in both situations. And many of them can also work out the voltage drop on the cable as well, and few of the verification checks. Overall, it gives you, it contributes towards overall productivity that what we're looking for. So let's go and have a look at it, and then we'll come back and see what gains that we have seen from this package. Okay. So let's go into SOLIDWORKS Electrical. All right. So what you're seeing on the screen is a SOLIDWORKS Electrical tool. Within the SOLIDWORKS Electrical, as you can see, it's a very simplified, easy on eyes, I should say, type of tool, and it's pretty common layout to most of the Microsoft style products, Office style products, because there's a tab up there, within below the tab there's a ribbon menu, so it's pretty easy to learn in there. Now within this tool, we also have got a help tutorial panel, so it's very easy to learn. You can follow the tutorials. Within the tutorials there are videos and everything like that. Now let's get into how do you start up a project. So you start up your project by simply going into the project manager, go to new, and then obviously pick up a particular template that you would like to work on. All these templates are customizable, and obviously based on those templates you can build upon your own project from there. Now I'm going to go and open up this project, which is already open, so I don't need to open that one. It's a project that I've worked on, and I'll show you some of the things that we have worked on there. Now, first of all, there's a cover page. Obviously, this will generate your own cover page with your own company logo. I'm just using a generic title block, not a specific company title block. Now, how does this title block fill in? There are attributes behind this title block that are reading information from various places in there. For example, this particular title block is actually reading all that information from this project card. Now again, and pointing towards the productivity gain with a single update from there. For example, I'm going to rename this, take this new off my stretch wrap machine name of the project, and let's call it AU/NZ. Made some modifications there and hit OK. And what this will do then, it will update every single title block in my whole project. So rather than doing 10 different places, it can be done from there. Now, what is also a cool tool, very important tool available in there as well. And what happens on there? This gives you a biggest snapshot of what's in your project. For example, there are 130 components in my project, and there are 27 PLC inputs and outputs, and there are 132 manufactured parts in there, which is that I need to order. How many wires? There's about 198 wires. There's 16 cables and different and some more. There is no harness, so it gives you a very quick snapshot of the whole project. Okay, let's click OK there, and this will update my title block there, electrical webinar, AU/NZ, and all the other information. It's also updated in there. Now, what if I want to generate a drawing register or drawing list of how many drawings I have in my project? So we can simply right-click in there and just update this drawing to get the most updated drawing. And that gives us a very up-to-date report that, for example, who has created this drawing, what is the name of the drawing, when it was created, who created the drawing, and what is the revision of this drawing. Every single report that I'll be showing you today can be exported into the Excel format. So no need to worry if you need to save those files or give these files in an Excel to your customer. And they can be customized as well. All right. Moving on to the next phase. Quite often, when you're either working on a machine or you're working on a plant layout, you can do the plant layout drawings in your basic 2D CAD package, or you can do within SOLIDWORKS Electrical as well, as there are drawing tools available right in there. You've got your all the basic 2D drawing tools available in these two tabs. Okay, now once this thing is done, you've got a layout, and within SOLIDWORKS Electrical, you can drop some component labels in there. For example, there, a component label there, component label all over. Now, what does it really mean? What does it really do? Once the component label has been drawn, you can actually right-click on it, and this will build up a link with the motor wherever this motor is represented, either on the single line drawing and its electrical schematic. So again, pointing to productivity, you don't need to navigate around and look for that particular drawing. You simply right click on the label and just click on that button 04, which will open the sheet number 4 and zoom in onto the location where that M2 is. Pretty easy to navigate around. Now that we're in this schematic type environment, not a schematic, you may rephrase the word like a system architecture or cabling block diagram. Now, zoom out so you can see what that looks like. Now, in order to draw a typical IEC symbol-based single-line diagrams, we can do that within SOLIDWORKS Electrical as well. Symbols don't have to look that picturesque as they are looking right now. Simply click on symbol, insert symbol button, go to other symbol library, and there are IEC symbols available for different type of drawings as well. So for example, if you need to insert a contactor or something, or a circuit breaker, we go and pick up the circuit breaker symbol in there. Simply drop that symbol, and this will automatically renumber that symbol, saying there's already 3 circuit breakers in the project called Q1, 2, 3, 4. The next available number is Q4, so we should use that one. And okay, and also gives you an opportunity to assign a manufacturer part number right away. So there you go. We can insert these symbols, and we can draw the cable, and we can draw the symbol and cable from that symbol to there, to that maybe terminal strip X2. Now once that thing is drawn and cable, you can simply double click on the cable and even assign what cable you will be using, whether it's going to be a 4-core cable, 10mm cable, all that decisions can be made right at the beginning of the project rather than taking all the way down to the floor level. So again, what cable you'll be using, or whether this is the right cable by doing the voltage drop calculation on that particular cable and things like that. So let's delete this cable. Now, within this drawing, you are seeing that I've got some outlines drawn or borders drawn called outside cabinet, and I've got this border called inside cabinet. Things like that can be drawn pretty easily simply by just, drawing this. Click on location outline, draw this outline on top of symbols, and link this outline to one of the existing location, or you can create a new location on the go. Now, what does it do? Why is it really important? As someone on the floor, he needs to know what components needs to go within the panel and what components needs to go outside the panel, things like that. And someone, from the commissioning point of view, if he's accessing the drawings, he also should be able to really pick up where these components are by looking at the drawing. So what it does, right next to, within the project, as soon as you draw those outlines, it actually groups those components within these two locations. So again, pointing out how easy it becomes to navigate a particular component. You can right-click on your project, just say search component, and look for the component that you are looking for example, M2, which is again my motor, number 2. So this motor is being represented on 3 different locations within the project. First place is a component mark, and we can zoom in, zoom out where that is. Second place, it's on drawing number 4. Obviously, we just looked at it. It also gives you a preview again. We can zoom in, zoom out. And the third place, it's been represented on sheet number 5, column number 4, row number 6. So instead of going through my whole list of drawings and then looking for the, that particular drawing, I can select this drawing, hit that button, closes, and that opens the drawing in the background for me. So again, very easy to navigate around the system. Now, how do we create this type of drawings? Typically, you would create wires one by one, or you might create multiple wires, multiple lines in there, and then you would put text onto it and the wire numbers and things like that. So I'm going to go give you an example how we can do that. So we click on, because I've got multiple wiring system, the multiple phase system, multi-phase, draw multiple wire, and we pick up what we want to draw. For example, 3 phases neutral with the protection, or I don't want to draw ground in that case, for example. Can I start my wires from that point? All 4 wires instantly coming up and join up to the right location. Neutral gets joined to neutral, first phase gets joined to first phase, and same accordingly all the other phases as well. Now left click will allow me to add the bend, and as you can notice, straight away I can add the bend in whichever side that I want to. A few shortcuts again shown, getting productive. We've got invert the space bar, for example. What if you want to invert the phases? Simply hit a space bar, and no need to click trim the line and then move and do extend, stretch, and all these commands. Just simply space bar will trim them. F8 will allow you to bend the wires into a certain angle that you wish to, things like that. Okay. Now, what if you want to insert the symbol? You simply click on Insert Symbol tab at the top, hit Other Symbol, and that takes us into the library of symbols as we go along. You can pick up circuit breaker symbol that you want, for example, 3-pole circuit breaker. Now, all these symbols are smart symbols. You don't need to rotate them if you want to place them on a horizontal line. And if you don't, you simply bring it to vertical, they become vertical symbol. Now, what if you don't have the lines on your schematic and you're just inserting the symbol first? You can simply right-click on your mouse, and that will change the orientation for you straight away. Let's put that onto my, drop it there. Again, it's asking the next available number for the circuit breaker is Q4, and this time I'll assign a manufacturer part number to that. Simply hit search, go ahead and pick up my library, and Schneider, because it's a 3-pole circuit breaker, so I'll go and filter for 3-pole circuit breakers only. So again, just to give you a reference idea how many parts are available in library, alone Schneider has provided about 40,000 parts. Rockwell Automation, Ella Bradley, again, has provided about 40,000 parts in there as well. And different manufacturers has provided a different number of parts. So I can pick up this multiline circuit breaker. Now on the latest library, it has all these symbols, multiline have been upgraded to Acti9 circuit breakers in there. Select. Okay. And all my terminal numbers and everything gets filled in straight away. Now, I'm going to do some Y numbering. Again, as you can notice, there is no Y numbering in there. In this project has about 10 pages of a schematic. So if you think of it doing schematics, including my PLC drawings as well, for example, this one, I'll open that in the background. There are no Y numbers at the moment on these schematics. So you think of doing 10-page schematic and then put text Y numbers on those. This could easily take up to 5 to 6 hours if you got about 100 to 200 wires on those 10 pages. So within SOLIDWORKS Electrical, simply click on Process, hit the Number New Wires button, and based on what formulas you have set, it goes through the whole project and numbers all the wires instantly. So including this drawing, including the other drawing as well, all the wires, as you can notice now, are numbered in there. Now, you can make the Y number formula as complicated as you would like to, or as simple as you like simply. So I've got 2 Y numbering formulas, or 3 different types of working here. First one is obviously 0543, which is a Y numbering shown. Sheet number 5, row number, column number 4, and row number 3, and 04 is the sequential number. And as you can see, this one is in row number 4 and under column number 3, hence it's picking up that grid reference in there. All right. So pretty easy to do the Y numbering. Now, what if you want to do some termination diagrams? We can right-click on anywhere on the terminal, or what if you simply want to put terminals on the schematics? So simply, we go into our schematics, insert multiple terminals, draw a line across the wires that we want to put terminals on, hit OK, all terminals. It automatically picks up the next terminal strip number, but I want to put those terminals on my X1 terminal strip. And it's telling me that the terminals available on that strip are from 21 onwards. So pretty straight away, I've got all my terminals in there. Now again, copy paste. Simply copy after selecting the symbol, and if we paste it there, it would take a fair bit of time to, when you paste a symbol within any basic CAD package, including DraftSide, for example, and a few other basic CAD packages, to renumber individual text on that. You simply copy and paste by Control-C, Control-V, and every single thing, including terminal numbers, cable numbers, and everything gets incremented to the next available number. So pretty smart this way. Press Control-Z, and that should take away that section. Now I'm going to show you how we can automatically generate the termination diagrams, because that's, again, quite an important thing. So you can right-click on anywhere on any terminal, whichever terminal you like. For example, let's pick up terminal number 8, and hit that button called Draw Termination Diagram of that terminal strip X1. So it goes through the whole project. Wherever this particular terminal strip has been used, it creates those diagrams. And as you can notice, this type of termination diagram has been created. And they're pretty straight away. All my terminal numbers in the middle. Left-hand side, I've got all the internal wiring with the Y numbers in there and the origin location where this Y number is coming from in there as well. For example, K1 contactor. And on the right-hand side, I've got the field devices with the cables connected to it, or individual cores connected to it as well, and all in there. And because this terminal strip was fairly, had quite a few terminals on it, so this has extended itself to the next page automatically. So you don't need to do the manual splitting into the pages or anything like that. Okay. So again, something that could have easily taken 2 or 3 hours, we've done it in a split of a second and got done like that. So huge amount of savings there already. Now, we've looked at that, and a couple of things that I want to show you is the automatic cross-referencing and how can we do that. So let's close this drawing. If you look into that contactor there, it's telling me that it has some parts of that contactor on sheet number 8 and 2-, which is row and column in there. So how do we get there? Instead of going through my list of drawings and looking for that particular drawing, I can right click on it straight away, say go to, and this will take us there straight away. So pretty easy to navigate between the drawings. Now, directly below this coil, it automatically draws a table of automatic cross-referencing. Now this table can be anywhere. You can put it on the left-hand side, you can put it on the right-hand side, wherever you would like to. What that table shows, where are the normally open contacts of this circuit, and where are the, if it has any spare contact or not. So yes, it has a spare contact. So how do we cross-reference with things? I'll show you a very easy way. We just simply go insert symbol, and the other symbol goes to our category of contacts, normally open, and pick up the right contactor, for example, this one or that one there. Simply drop it in my schematic somewhere there, and I'm going to just say, hey, this is a part of my K3. And straight away the K3 gets filled in. So you can see how easy it is to do that. Now, one of the biggest trouble that I quite often used to run in when I'm doing schematics, what if you move things around in the schematic? So I'm just going to close a couple of pages, and let's go to window and make it vertical and zoom in there. So what if I move K3 on the other page and you forget to update this cross-reference information on that? Then that's just the wrong information being provided to your customer or the guys on the floor wiring up the system. So with SOLIDWORKS Electrical, don't need to worry about that. It's instant. You move the set contactor, and that table gets instantly updated with the latest location of that instant 3D normally open contacts. Put it back, and that will get updated instantly as well. So you don't need to do any manual updates. Again, quickly showing you a very powerful feature. What if you decided to change the name of this K3? So you don't, and because it's been represented in multiple places, you simply double click on that and just go, I want this one to be called K35. And hit OK, and it's just called K35 everywhere. So pretty straightforward. Put it back to K3 again. Okay. Now, the next thing I'm going to show you the PLC, which may not be for everyone attending the webinar at the moment, but there is quite a large audience that might be using PLCs in there, and I was just going to show you how we can integrate SOLIDWORKS Electrical with lots of other PLC programming softwares out there. So, but before I go there, just quickly show you a lot of companies working with within industries, like for their building maybe communication racks. They may be working for defense industry and things like that, and their electrical drawings typically have lots and lots of connectors. So how do we work on that? So I'm just going to quickly right-click on that and just say new, create myself a new schematic. Once I've got the new schematic, new blank page open there, we hit the button called Insert Connector. Create a new connector. Hit Search, and it gives us I've got Deutsch connectors, I've got Glen Eyre, I've got different manufacturers in library. So you pick up this 12-socket connector in there. Hit OK. Okay. And straight away, it draws that symbol for me with all the pins in there. Now, if I don't want to show all the 12 pins of the connector, only 10 pins, or maybe untick the pins that I don't want, and the symbol connector straight away is much smaller. And I can then draw other 4 pins at any other page that I want to, for example, directly below there, part of the same. Now, insert connector again, create a new one. This time I'll pick up a pin instead of sockets. Okay. And obviously change the direction. Now I'm going to go, and I don't want these pins again. I'll just take them off so you can see. And quite quickly, I can drop this connector there straight away. And again, I can do the same thing with this connector. So you can see the difference between the internal symbol that's telling me that these are the sockets and these are the pins, and that's the automatically generated symbol. Again, to draw a bunch of wires between them, we can select how many wires you want, for example, 7 of them. and straight away we can join all these wires in there. So I should move this one down one below, and then draw all my wires in there. Right click and we'll trim all the wires accordingly. Again, you can see quite a lot of time has been saved just using those smart tools. Pretty easy. So this time I don't need 7, I can go ahead and 4. So you can see how easy it is to create schematics for the harness drawing in there as well. Now, back to PLC. Again, we're going to go right click in there and just go ahead and create myself a new schematic. Just a blank page so we can insert some PLC card in there. Okay, there could be several ways. There's a lot of these days work with modular type PLC. There's the IOs in there, and quite easily we can simply build up a PLC by right clicking on there and go, go PLC mark and create all of that. Or we can just go insert PLC, simply create a. Do you want to create a new PLC? Just go yes, hit search. Alan Bradley, for example. I've got all my 1747 or maybe 1761 Micrologics controller. Select that up, hit OK, and I can pick up whichever orientation I want to insert my card in, whether horizontally or whether vertically. So whichever, and then you just simply go and select the ones inputs or outputs that we want to. For example, I only want to insert 15 of them, so take all of them, and it'll draw the card for those 16. Or I'll just go ahead and insert and take the ones that I don't want maybe. It draws much similar. So you can choose how many inputs are fitting, or you can tell it to automatically generate the ones that you don't want it. It can fit the card automatically on the page as well, so you don't have to go and draw all in there. So straight away, you can see I've got my card in there. You simply select them up and activate them, and it draws that card for me right away. It's a pretty easy way. Now, what if you want to insert some information like text and things like that? You can right-click on it simply and just go add, and then go edit the PLC and things like that. So very easy to generate the PLC. It's also created this new component called A1 within my PLC diagrams in there. We can quite easily edit that PLC should we need to. As you can see on that PLC, we've got those bunch of IOs. In there, we can select them up, generate them. And if you want to bring in some information, for example, such as our inputs and outputs, we can click on all those outputs available in there, data grid, and here I am with my Excel spreadsheet, because every programming software can give you Excel spreadsheet. Simply copy paste all the text, put in there. Hit OK, close, and all I'm going to do this time, as you can notice, I don't have any other drawing after 56. Tell it to generate the drawings for that particular module. Done. So it's generated all the cards in there with all the text information and every single thing in there. So pretty easy to generate all your cards and split all the cards based on whatever page that we had. Now, as you can see, we've already saved a lot of time by getting rid of this manual text entry in the PLC diagrams. All right, now we've looked at quite a few things automatically that we can do. Just to wrap up a few things, how we can do the panel layouts within there as well. We'll just go ahead and see some of the reports in the panel layouts, and pretty much we are almost done with this 2D side of things. So we'll just go and give you an idea of how can be done with the panel layout. Now I'll just open this blank panel layout drawing, or panel layout drawing with some panels. But how did I create this panel layout? Simply go into Cabinet Layout tab. We add the DIN rails, ducts, or cabinet as we need to. On the left-hand side, these are the list of components that we need to insert in our, it's telling us that what's in your schematic that you can insert in the cabinet, basically. So simply add the rail, search, DIN rail, select this DIN rail up, put this DIN rail up there, And it gets confusing when you have too many parts there, which one you have inserted, which you haven't inserted yet. So just click on this button, hide already inserted components, and it's supposed to hide all the component that has been inserted already. So right click and see insert and symbols for these multiple parts should we need to. For example, I'm going to insert all my terminal strip, insert my terminal strip, okay, and simply put my first terminal on the DIN rail. It's going to place the whole terminal strip on that DIN rail straight away. And now if I want to see where this particular terminal number 9 is within my schematic, you can right click on it, go to, and it will take you straight away where that terminal number is. So very easy, again, to navigate around in there. Now reports, some of the reports that we can generate out of it, for example, a list of cables. What cables you've got in that particular project is a very easy to read report in there as well. PLC IOs, what IOs you've got in that particular project, it'll give you a list of that as well. List of cable strands, for example, how many with W1 core cable. I've got cable with 4 cores going origin destination of each individual core, and then the wire number. The wire number, I can simply right click on it and say yes, because the wire numbers have now been done. It'll populate the tables with the wire numbers as well. So you can see how instantly you can do that. And vice versa, you can right click and generate the list of wiring tags. So all my wire tags with the right quantity gets listed in that very report, which can be exported into the Excel format. Okay. So that's a brief overview of SOLIDWORKS Electrical, how powerful it is and what it can do in various different applications in there. Now I'm going to go back to the presentation and see what we just covered up, what we have looked at it so far. Okay, so we saw how we can get productive by using intelligent schematic tools, shared and search libraries. We can automate manual tasks such as wire numbers, component marks, cross-references, PLC IO management, single-click termination diagrams, bill of materials can be generated from 2 reports, voltage drop in there, and all the other collaboration among all the different phases of projects. So in general, if you put it on some numbers, for example, if you overall putting about 24 hours to do your schematic design, you pretty much spend similar time in SOLIDWORKS Electrical to do the schematics as well. So not a lot of gain there because you're still putting symbols there. Yes, there's some productivity gains there, but not whole heaps. Where we see and predict the most productivity gains is the tasks where you do like on the manual tasks such as wire numberings, device tagging, cross-reference management, terminal strip management, bill of materials, from to list, and everything. Overall, we reckon it could save you about 30 hours per project if you're spending about 53 so it's a huge productivity gain in there, and there's some percentages as you can see in there as well for each and every individual task. So these are the commonly used tasks that what I use to spend a lot of time in there. There are a lot of other tasks that we can be automated that we haven't even looked at yet. And just a graph showing obviously the light blue one is the sea green color is SOLIDWORKS Electrical, and then dark blue one, the navy blue, is SOLIDWORKS is basic CAD package that you could be using in there. All right, now just to quickly, we've only got a few minutes left, so I'm just going to highlight a couple of points on the 3D, how we can overall, if you are working with mechanical team, how we can improve the overall design process. So we've seen the improvements on the electrical schematic design. So typical process, what we've seen, companies involved with the schematics and mechanical design, and they do a lot of integration, so manually, obviously, and then you get to the production. It's a serial process. We offer like a parallel process in there for overall improvement in the productivity cycle, basically, or design cycle, with the help of SOLIDWORKS Electrical 3D. So what is 3D? For most of the guys who have been working with SOLIDWORKS in the past, using 20 odd years now, to do the machine design in 3D or anything in 3D. So up until now, for example, putting in biological terms, if you could do body in SOLIDWORKS, now you can also do a nervous system of the machine with the help of SOLIDWORKS Electrical in there as well. So all the panel layout gets done in 3D, all the wires gets routed, all the cables gets routed to the right place as well, and in the right colors obviously within the panel as well. And we can also do 3D harness drawings within there as well. So let's go jump into SolidWorks, and I'm going to go open my project basically just to show you how I got there within the SolidWorks. I've got this tool there called Tools, SolidWorks Electrical, Project Manager, and we can access the same Project Manager in there. So I've opened this particular project in there, in which has a control panel, and similarly what you saw in the panel layout within the SolidWorks Electrical 2D, we have the list of components available inside 3D as well. So we can again do the similar things as well, hide already inserted component, and we can see what we need to insert. So just like we inserted our 700 strip, we can insert the parts in the 3D as well, right-clicking, insert. It picks up the 3D model of that contactor from the 3D library. So we can drop it onto the general, gets automatically snapped onto the general with the help of auto snap in there. Now, once you place all the components into the panel as you want to, because we are in 3D, we can do a lot more cool things as compared to just the 2D panel layout. We can actually route all the wires in there. Now, this is going to be pure automatic route. I haven't done any pathway for the wires apart from, I'm just going to highlight one of the pathway, which I'll zoom in. Select this pathway, and as you can see, this orange line in there, which is highlighted. That's the only small sketch that I draw in there, just to give a rough guided pathway from the panel to the door. So the process that it's going through right now is just reading what's in the schematic, which component is connected to what component, so you can connect those components with the right size of the wire as well, following the segregation rules as well, because I've told it not to put control wires in a particular tray, and I've told it not to put power wires in the other trays. So it's a very quickly, we'll say, all the wires slowly getting routed and getting in place from the schematic basically. So it's a schematic driven routing. It's a different from traditional routing where you would manually start from two, and similar routing can be achieved for P&ID and also for pneumatics and hydraulics in there as well. So once that's done, it'll come back with a list of errors that I have in my routing assembly. So you don't need to go through individual and trying to find out and troubleshoot what are the routing errors. It will give you straight away what are the routing errors. If you are missing some C points, if you overuse some C points, and things like that. So obviously you can, to make things quicker and keep assembly light, you can tell it to generate just a sketch routing rather than solid routing. Solid routing actually draws the wires and cables in 3D with the right curves, depending on the bend radius defined by the manufacturers of each cable and wires in there. So we're almost done. In there. Okay. So just giving it a final touch, basically, just adding last 1 or 2 wires that it needs to be added. And that comes back with a analysis, what needs to be in there if there are any errors. Obviously, there are a few errors. I'm missing 3D parts for a couple of things and things like that. So those are the errors I had in my system. If I zoom in, you can see exact colors being put into their right place and everything. And the benefit of using this technology, the effect of having 3D on your 2D side, is if you go back to the 2D, we can straight away see in the reports. For example, if I open my list of wires, there's a length of the wires coming in there as well, telling 24-volt AC wire being used in these locations from 2, and then telling the individual section length, and at the bottom it tells you the total length required for that type of wire. So length comes from the 3D side. So that's pretty much what it is. To wrap up this presentation, we export the documents to PDF. We can do it like a batch print, and we can just go drawings, and that will include every single report that we currently have in the project. We can export the drawings and save them into DWG format, give it to your client, or you can export them into e-drawings. You can export the data of the project into Excel, make some modification in Excel, bring it back into the SOLIDWORKS Electrical, and that will update all the tags and things from that as well. So I'll just show that PDF, and then I'll take questions basically. So that PDF has about 39 pages, as you can notice. All the reports and gets in there as well. Within the PDF, it keeps the links, for example, from M1 motor. If I click on it, it will take me exactly where that motor is. In the single line, if I click on it again, it will take you where that is on the schematic. So all these things are linked within the PDF as well. It also creates a list of components, exactly the similar way we had in SOLIDWORKS Electrical. And we want to see, if the guy on the floor has an iPad or a computer, for example, you're commissioning and you have a computer and you want to know where that contactor 3 is, K3. Obviously, first place it is on our single line. Second place, it's on, our drawing schematics, which 3 normally open contact. I want to know where the coil is, or the relay coil. That's where the relay is on that page. And I want to know where that is in the panel, and that's where it is in the panel. So it's all linked within to the within the PDF as well. So I'll just take it back to my presentation thing, and some of the benefits we've seen, what we can do, and we took a look, and take any questions if there are any questions. Okay. So I'll stop the recording of the webinar, as this will be published on our YouTube channel.